I am Dr. R. Lalitha Narayana, Mechanical Department, Swarnandhra College of Engineering and Technology. Today my topic is shear force and bending moments. Shear force and bending moments. What is the shear force? What is the shear force? Shear force means algebraic sum of vertical forces from any section of the beam. From any section of the beam. So that is the shear force. Bending moments. Basically, moment is force into perpendicular distance, that is moment. Bending moments means algebraic sum of moments of vertical forces at any section of the beam. Algebraic sum of moments of vertical forces at any section of the beam, that is bending moment. Next, SFD. SFD means shear force diagram. So shear force diagram means the variations of shear force along the length of the beam, that is shear force diagram. The variations of shear force along the length of the beam is shear force diagram. Next, bending moment diagram. The variations of bending moment along the length of the beam is known as bending moment diagram. Types of beams. First one, cantilever beam. Cantilever beam means one side fixed, another side is free. Side means end. One end is fixed. This is the beam. Suppose one end is A, second end is B. So at A end is fixed, another side is free. So that is the cantilever beam. Simply supported beam. Simply supported beam. Simply supported beam means both ends are supported by some supports. So this is the beam. This is the one of the support is other support. So both ends are supported. That means simply supported beam. Next, third one, fixed beam. Fixed beam. Fixed beam means the both ends are fixed. So fixed means in cantilever one end only fixed. So that same scenario in both sides. The both sides are fixed. That means the fixed beam. Next, continuous beam. Continuous beam. So continuous beam means more than two supports. More than two supports means this is two supports. Two supports means only simply supported. The supports more than two means three or more. Four supports also continuous beam. War hanging beam. Overhang means beyond the support the beam is carrying, beyond the support. So this is only up to this simply supported beam, but in this case the beam is continue beyond the support, that is the overhanging. So that means overhanging beam. Sign conventions. Sign conventions for SFD. Suppose take some small blocks from the beams. Suppose load acting here and another here. So what about this? This is the clockwise. The load is upward, the load is downward. That means totally clockwise. Clockwise means the shear force is positive. Next, the load is here, another here. So this means anti-clockwise. Anti-clockwise means the shear force value conversion is negative value. Sign conventions for bending moments. So the bending moment is, the beam is curvature. So this curvature is upper curvature, lower curvature. The upper curvature is concave. This is the lower curvature is convex. In case the beam is curvature in downward direction, this is convex, concave, this is convex. Suppose upper layer is convex, that means the load is here, the load is downward direction. The upper curvature is convex, that means positive. The lower curvature is concave, that is negative. So this means positive, this means negative. Which value positive, negative? Bending moment value is positive. Next, so this case positive means in this case the beam is sagging. So this type of curvature is sagging. So this type of curvature means hogging. This is the sagging, this is the hogging. Next, I will explain about problem. So take one problem. In this scenario, different cases are there. So different case means, for example, case 1, cantilever point load, cantilever UDL. Cantilever point load is the one case, cantilever UDL is the second case, cantilever varying load is the third case. Next one, simply supported, again continue, point load, simply supported beam, point load, simply supported beam, UDL load. So in some cases cantilever beam with combination of loads. So I would like to explain about cantilever and point load. Okay, this is the cantilever. So cantilever means one side fixed, another side free. So this is the cantilever. So case 1. Cantilever with point load. This is the cantilever, the point load is here. So the point load value is W. So the length of the beam is small l. So the both ends is, the fixed end is noted as A, free end is B. First calculate the shear force, then draw the shear force diagram. Next calculate the bending moment, then draw the bending moment diagram. So first calculate SFD. So shear force at B. Shear force at B means F of capital B. Okay, particular point B means this point. So algebraic sum of from left side. So from B section, right side no forces. So no forces, but particular point acting some point is there. So that point is B, the load is W. But the W is negative or positive, so depend on clockwise or anti-clockwise. Okay, one A section is fixed, the point B is downward direction, this also clockwise direction, so that means positive. In case newtons, no? W newtons. Next, SF and the shear force at A, F of A. Shear force at A. So according to the definition, algebraic sum of vertical forces from right side. Algebraic sum. So have only one point load, no point load. In case another load is algebraic sum, but here only one point load only. So W okay, shear force at A point also, shear force F of A is W, this is W naught. So but this is value positive or negative, check it. So this is fixed, so this value is there. So up to here algebraic sum. So algebra no point loads, no UDL loads, this load is only. So this load also acting downward, again the beam is in clockwise direction. So this is also positive. So positive W newtons. Next going to SFD. So draw the SFD diagram by using the shear force. First of all, indicate some reference line. So reference line means the reference line is the zero value. Shear force value 0. So in case above that line positive value, below that line negative values. So here only positive values. So but take one reference line. So this is the zero line. Zero line means shear force is 0. So at B point shear force is W, positive W. So for example mark here, this is the W. Next at B point W and A point also W. Between the AB no variation is there. So W is carrying up to A point. So this value W, this value also W. So after draw the SFD, the inside is draw hatching line only at border line only. After that indicate the sign convention in the diagram. This sign convention is positive, that means positive. Also indicate the name SFD. This is the shear force diagram. Next BMD. bending moment at B, M of B. What is the bending moment? Vertical forces and perpendicular distance. Force into distance is the bending moment. Next, bending moment means bending moment diagram, algebraic sum of all moments of vertical forces. So according to definition, bending moment at B point is at B point at right side no forces. No forces means 0. At particular point B point also force is there, but distance is 0. For example, the force is W, but that point into vertical force into distance. The distance is 0. That means 0 bending moment at B point. Next, bending moment at A. That means M of A. According to definition, algebraic sum of moments of vertical forces. So from A, how many vertical forces? Only one vertical force. So the vertical force is W. Next, moments means vertical force into distance. So distance from the B up to A, the length is L. So WL is the force into distance moment. So what about sign conversion in bending moment diagrams? So sagging or lagging. So this load is acting here downward. This is negative. In this scenario, concave upward, concave downward, convex upward. Concave upward downward means negative. So is all load is downward action. So downward means negative value. So the bending moment is negative. Next, draw the BMD. So in this also take the reference line. So this reference line is 0 value. In SFD the 0 value is shear force 0. In this BMD value 0. So in case negative means below, positive means upward of this reference line. So BMD 0 and negative. So BMD at B point is 0 and bending moment at A point is some value WL for take some distance WL. Next, what about this linear line or curve? So linear line. Linear means the force effect with respect to length of the beam. The momentum is variation. So the moment is variation means linear variation. That means straight line. After this, inside of the border, draw the hatching line and indicate the sign convention. This convention is negative and indicate the diagram BMD. So this is the case 1, cantilever with point load, SFD and BM diagrams.